this problem is going to cover another optimization model that uses binary, and this one is going to focus on deciding which cities to use as hubs for an airline. So again, the first thing we are going to do is identify our decision variables, which in this case is going to be used as hub. So we're going to go ahead and grab these, highlight these variables. We also have to deal with the constraints set forth in the problem that each city is required to have at least one hub. So we're going to go down, put ones in for all of these. And our objective to minimize is going to be the total number of hubs. Okay, so the first thing that we are going to calculate is how many hubs serve each city. So this is going to be a sum product. And the first thing we're going to grab is not that range, not sure what's going on there. Okay, we're going to grab our decision variable, because if it is 0, then it will cancel out with the other, the next line. And if it's not 0, then it will end up being 1, because this is also a series of zeros and ones. We're going to go ahead and make this an absolute value so that it copies and pastes easily. And then the next thing that we're going to grab is the cities. And so what you can see here is that Atlanta is the first city, and the cities that can use Atlanta, or the cities that can have Atlanta as a hub, is Atlanta, Chicago, Detroit, whatever this HO is, NO, New York, and PL. I'm not sure what all those cities are, but it doesn't really matter. Okay? And then once you've got that, you can copy and paste this formula down. That'll save a lot of time from having to re-enter it every time. All right. This is a fairly simple one, so the next thing that we get to do is go ahead and solve. So we want to make sure that we are minimizing. Oh, you know what? We can't solve yet because I haven't calculated the total number of hubs. So we literally just are going to sum our decision variables. Okay, so it's pretty simple. All right, now we can use solver. All right, so our total hubs is our objective cell. We are going to set it to a minimum because we want the least number that we have to have in order to meet our constraints. We're going to change our decision variables, and they are going to be binary, so we can go ahead and add that constraint. So a city is either going to be a hub or it isn't going to be a hub. All right. And we're going to set that to binary, and we've got to add one more constraint, and that is that each city has to be covered by at least one of the hubs. And since we put one in there for all of these, we can just go ahead and select those two ranges. Okay, so we do okay. Again, make sure that we get simplex LP. And okay, now you might have gotten a different solution because this is one of those models that has more than one ideal solution. So the objective to minimize always comes out to be 3. My solution has ATBO, which is probably Boston, and SL, maybe Salt Lake City. Anyway, those are the 3 hubs that would have been chosen in this model. If we goofed around some, we might be able to make it come up with a different model. Let's see if we can get it to show us a different set of cities. No, my solver went back to the same, but again, it does have more than one optimal solution in that as far as which cities actually served at hubs, but you should not end up with more than 3 total hubs. I'm not going to take time goofing around and too much more time goofing around trying to show you that, but it may come up on yours, and if it does, it's fine. It just means that there's more than one optimal solution. Okay, now we're not going to do a sensitivity on this one. Your book does give you an option to go back in and add miles and look at how the ideal solution would be adjusted if the sensitivity range from 800 to 1200 miles from a city that could serve as a hub. Anyway, this one is set at 1,000. We're not going to do that. We are going to go ahead and go on though to another problem, and that is locating service centers. The reason we aren't doing the last one is because this one also deals with miles. So the first thing we're going to do here is locate our decision variables, and our first set of decision variables is whether or not to include each city as a service center. So we're going to go ahead and grab those as a decision variable, and we have a second set of decision variables in this problem, and that is if a city is a service center, what city does it service, or what cities does it service? So we have two sets of decision variables, and in this case both sets of these are binary. So one of our constraints is that we can't have more than 3 service centers total. So we're going to sum these, and we're going to constrain that number that it has to be less than or equal to 3. So the next thing we're going to look at is the number serviced by. So how many service centers can service each city? Okay, and we are going to go ahead and sum that. Oh, I'm sorry. This is actually how many cities can be serviced by each city center. So go ahead and pull that all the way across. Next, we have to figure out what our logical capacity is. And the service centers cannot service more than 11 cities. However, that is only if they are a service center. If they are not a service center, they can't do any. So again, we take our first decision variable, which is whether or not, for instance, Boston is a service center, and then we are going to multiply that by 11. And so if Boston is not a service center, then the logical capacity for Boston is going to be 0. If Boston is a service center and it's a 1, then its logical capacity is going to be 11. So this number is going to tell us the number of cities serviced by Boston, and it is not going to allow it to exceed the logical capacity for service by Boston. Now, the next set of numbers is the annual trips and the total distance. The number of annual trips taken to each city is given to you in table 610 on page 325. So for Boston, that number is 885. For Chicago, it is 760. For Dallas, it is 1124. For Denver, it is 708. For Los Angeles, it is 1224. For Miami, it is 1152. For New York, it is 1560. For Phoenix, it is 1222. For Pittsburgh, it is 856. For San Francisco, it's 1443. And Seattle is going to be 612. Now, we also have to calculate the total distance traveled to each city, because that is what we are trying to minimize with our solver problem. We want to minimize the number of miles that the representatives and the company have to travel. So first of all, we are going to take the number of trips that occur to Boston, and then we are going to multiply that number by the sum product of the trips to Boston. So that's B23 to L23. So that, I'm sorry, that's the number of cities that service Boston, the number of hubs that service Boston, and then we are going to multiply by the mileage for each. Okay. And then we can just copy and paste that formula all the way down. There's one more constraint we have to put in, because each city can only be serviced by one service center. So we need to sum the number of service centers assigned to each city, and we can multiply that all the way down, and we are going to constrain that to be 1. Oh, went a little too far there. Okay. All right, now we are ready to put all of this into our solver. Go to solver, and we are going to, oh, we are not ready to put this in solver. Sorry about that. We have not calculated our objective cell, which is our total distance. And our total distance is going to be just the sum of the total distances. Okay, now we are ready to use solver. And so we are going to set our objective cell, which is B53, to a minimum. We are going to do that by changing our decision cells, which are B19 through L19, and B23 through L33, and then subject to the constraints. And then there's quite a few constraints here. Let's get our binary constraint in first. Okay, so we're going to constrain all of our decision variables to be binary. We're going to add a constraint. It's not liking that for some reason. Okay, let's break it up. It may not want to do the non-adjacent rows. So let's do B19 through L19 and binary, and then add, yeah, I think it was the non-adjacent rows. And then grab the other set and put those to binary, and we can go ahead and add. Sorry about that. All right, so we're going to take our service centers and we're going to make those be less than or equal to our max service centers, which is found in cell O19. Then we're going to add a constraint that our total assignments have to be equal to 1. And then we're going to add another constraint that the number serviced by a service center has to be less than or equal to the logical capacity of that service center. And that should be all of the constraints that we need. So make sure you're set on simplex LP and go ahead and solve. So our solution is pretty close to the one that's in the book. The main difference is that I did not put my total distance in thousands of miles like they did. If you wanted to, you could stick that whole thing in, that whole formula in parentheses and then do divided by 1,000. But it is essentially the same solution that is in the book. So whereas they have 5,145, you have 5,444,521 miles as your total distance. Again, essentially the same solution. Yours just isn't in thousands of miles. So that is the basis for how to do this particular problem. Again, there's more constraints than you've had to deal with, but they're not hard constraints. You just have to sit down and logically think through those constraints. So if you were going to present this to your manager, let's talk about some of the things you would discuss. First of all, you would discuss that you had service centers in Dallas, New York, and San Francisco. And then you would discuss which cities were serviced by each. And so San Francisco is going to service Los Angeles, Phoenix, San Francisco, and Seattle. Okay, and that's going to be a total of 4 service centers. New York is going to service Pittsburgh, New York, Miami, Chicago, and Boston, and they're going to have a total of 5 cities that they service. And Dallas is going to service 2. They're going to service Dallas and Denver, and that allows you to get the number of miles traveled by the employees to a minimum. I hope this has been helpful. As always, if you have any questions, please feel free to call, email, get in touch with me, reach out. I am happy to help you if you need help. Hope you have a great day.